Hey there! I got a cool one for you today. We're going to be looking at Houdini 22's new Heightfield COP nodes, more specifically how we can use those nodes in conjunction with some of the adjacency nodes to create seamless height fields and apply them to 3D objects. So this is pretty awesome. We can use it to create these little stylized worlds like you see here, and we'll be looking at that along with some other tips and tricks. Let's get into it. Okay, so let's walk through this here. I'm not going to go deep into all the different height field nodes because there's tons of tutorials on that. But the basic concept here, I'm going to go ahead and type HF COP and then put down a height field COP network. And this sets up a few things for us automatically. It creates a bigger sized scene, and I can put down a height field in here. And then you can do your normal height field operation. So I could do a height field noise and use this layer as a size reference. And now I'm getting some terrain just like normal. And you could mix together different noises. Could put another one, experiment with maybe a whirly noise. Since we're in COPs, it's very powerful. We can mix things together. Could add a minimum merge node, blend node here, and start kind of combining different noises together to get interesting results. This is all good, but how do you move this onto a 3D shape? And I just realized, I don't know why I'm leaning so far over to the camera here. That's sort of the trick here. So I'm going to be walking through how we translate height fields, which are inherently 2D volumes, right, onto a 3D surface. So let's jump out of this COP net. That was just sort of a very quick intro to the COP nodes. Okay, so let's exit COP land for a second and look at creating the actual 3D geometry that the height field will be applied to. So we just, in this case, want to make a sphere, a tiny planet. So this workflow could apply to any sort of 3D object, the same as any adjacency workflow can. But in our case, we're going with a sphere. And one way I like to do that is just take a box and subdivide it. That makes sure you don't have any poles on the top and bottom. You have these tangent points coming in at the corners instead. And then one thing that I sometimes like to do when I'm wanting to make sure something is perfectly spherical is just normalize the position. And so that's all this point wrangle is doing, is I'm taking the position and just normalizing it. And you see that just pops the sphere into a 1 unit radius. And then I'm UVing the sphere, nothing fancy. This should pretty much work. You don't really want to have awful UVs, but should work with pretty much any sort of UV layout. So I just use the lab's auto UV to create a quick UV of the sphere. Ran a UV layout, minor change, and then I applied normals. And then this last part is basically making the sphere quite big. So height fields are coming in thinking you're working on a large area. Right now, this sphere is just 1 unit in the radius. So I'm going to use the match size node here just to increase it to 500 units. So we get this big sphere. That's the geometry we'll be working with to create our planet. So we have our planet. We have basically just a UV sphere, nothing too fancy yet. And now let's jump into the height fields. Okay, so jumping into the height field here, first step is to bring in our geometry into the COP network. So this is the same. We use a SOP import, and that allows us to bring in geometry into our COP network. Now we can use the Geo2 adjacency workflows here in order to eliminate seams. So this adjacency stuff, a big part of it is eliminating your UV seams so you can have seamless textures. So the main workflow here, there's some good tutorials on this that I'll link below. So learning all the adjacency nodes isn't really vital for this. I'm going to show you how they apply to the height fields. But in general, you're starting with a Geo2 adjacency node, plug in your SOP import into the geometry, and you can see I'm connecting this height field layer just as a size reference. This would work fine without this, but it's nice to have in case I needed to change something, but this isn't really needed. And so this Geo2 adjacency node is basically like your setup step. It's creating all the different attributes that are needed to run all the adjacency nodes. So there's a few of them we're going to be going over. This is just the first one. It preps everything, and it's piped into all future adjacency nodes. And you can see here there's like a little cross symbol. This means it's a cable. So if I do a cable unpack, this isn't unique to adjacency. It's basically just a layered texture you could think of a cable as. And I can say set fields from input, and you can see this adjacency cable actually contains a lot of different data in it that is used by these other nodes to eliminate seams. All right. So the first way we can use this with height fields is by throwing down an attribute sample from adjacency. So I like to just type adjacency, and you'll see all these nodes come out. And so this first one that I'm using is attribute sample with adjacency. And so what this does is creates essentially a seamless position map that you can use to drive 3D noises. So if I pipe that into a height field noise, you can see it sort of looks weird. Let me go ahead and put down this height field noise without the position as well, and we can compare. So you can see height field noise by default, it's a seamless noise on this 2D grid. But if we apply that to our sphere, which I can preview right now by putting my display flag, this is new in Houdini 22, to geometry mode on my SOP import, you can see as you apply that noise, we get all these nasty seams. So we can't just apply that 2D texture, that flat kind of height field onto a sphere without dealing with this. So that is what this adjacency sample does. So notice the difference when I preview this. We have seamless textures on a 3D object, a seamless height field noise coming into the 3D. So that's super awesome. So you can use basically all your height field noises, which are basically just fractal noises set up to run on height, to drive deformations on any object. So this could be applied to any sort of surface. So that's the first sort of trick here. We're using this adjacency attribute sample as the position for that noise instead of just letting it use that world position and results in seams. It looks good on 2D. So if I click X over my viewport here, you can see that toggles this geometry preview. So I'll be doing that throughout to just show you the difference. You can see a regular height field looks good in kind of your flat up and down 2D space, but when you put it on a 3D surface, the UV seams start to become a problem. All right, so adjacency fixes that. So the other big thing, let's just walk through this node structure. I put a height field terrace. This is kind of over. It looks pretty crazy right now, but once you start running erosion, it gave a good effect. So the height field terrace didn't really introduce any seams. I didn't bother doing anything with that. That sort of worked. The other thing to consider that is really hard to have seamless is height field erosion, which is really like the main sort of reason or one of the main reasons to use this methodology. Having all that erosion simulation really lends a nice look to your terrain. You could use this same workflow and just mix noises together and make like a stylized planet pretty easily without erosion, but the erosion needs a few more steps because we're actually simulating. So let's look what happens when we run the erosion on that terrace. So just kind of this is a little spaghetti like, but we'll walk through all this stuff in a second. So this, I'm just branching it off so you can see what happens when we use erosion. Since we're eroding on this 2D plane, it will create that UV seam problem again once we translate that onto our 3D geometry. So we can see here all of our UV seams are starting to show again because that Heightfield erosion isn't aware of the adjacency. Some of the new COP nodes do have adjacency aware nodes where you could like just plug in adjacency right into the node and it would not have any seams, but Heightfield erosion doesn't. Maybe in the future that would be something cool that side effects could add. So how do we fix this? There's a couple of ways I've been experimenting with this, and this is all brand new stuff, so there might even be better ways. But one way is to use another node, adjacency extrapolate. So this node is attempting to basically extend the boundaries of your UV islands in a way that they connect with each other. So when we pipe in the texture, which is our Heightfield, into the first slot of this extrapolate, and we're always going to be referring back to this geo-adjacency node. So anytime you see an adjacency input in these nodes, it's always just linking back to that source geo2adjacency setup node here. So when we connect both of those up to the extrapolate node, you can see that sort of like sews up the geometry, kind of. Like it's not great, but it at least doesn't have that big gap anymore. So we can see before, after, but it's still pretty crunchy. This was one thing I was exploring here, is basically taking a mask of these UV seams and sort of filling in those areas, in painting it with the original Heightfield to get rid of that sort of harsh line right there. You can see like the Heightfield is sort of stretching along it nicely, but we're still getting that visible seam there, which is unfortunate. So that's where I was experimenting with setting up a little mask so then we can mix in our original Heightfield just to hide that. So you can see like at a glance, that sort of eliminates any seams you're seeing on your 3D surface. If you really got in and inspected the before and after, like when I rotate around, you probably can't tell, but you can kind of see a little bit of like a divot there. That's where that seam is occurring. So before, after. But that's one way of dealing with it. And so let's dive into how I did that. I'm created this little subnetwork here, and what this is doing, I collapsed all these down into a network just for organization. What I'm doing here is I'm taking this source adjacency node, so going all the way back, it's always going back to this setup node, and we are using a cable unpack to isolate the mask of my UVs. So you can see cable unpack, mask, and this is just literally my two UV shells. And I'm inverting it and dilating it essentially just to isolate the border. And you could use a edge detect in this case, but I found that just manually dilating is a little faster. So you can see if I zoom into these, we have like a positive and a negative, and they're slightly different sizes, and when we blend them together with a minimum operation, we have that mask. And so if I go back here on one of these dilates and adjust the radius, you can see this is able to control essentially this seam. It's basically a mask for the seam here. So if I go all the way to the end, I'm jumping ahead here. Let's just keep going going forward here. And so I have this sort of isolation mask for the UV seam, and I blur it a little bit, I brighten it up a little bit, and these you can kind of play with based on your Heightfield and where your UVs are and based on the geometry. But I just if you're following along directly, I blurred it just a little, 0.0133 image units. I brightened it up 1.22 units here. And then I'm using this adjacency extrapolate node again, just to bridge any seams between these two UV islands. So I plug in my texture, plug in the adjacency, and that helps a little bit. It looks very weird when you're looking at it in 2D, but that gets rid of any little overlaps that occurred while we were making that mask. Now, if I just had that applied, it was a little bit too smooth of a mask. So what I did was use another adjacency node, adjacency distort, to sort of roughen it up a little bit, just so it looked a little more organic. So here I'm using the same adjacency sample workflow to make a fractal noise that is seamless on the plane. So that's exactly the same thing that we did right at the start with our height field noise. We're sampling the position to drive a noise to make it seamless. Jumping back into here. And we're creating a slope direction for that, so we can then feed that into another new adjacency node called adjacency distort. So this is the same idea as your distort by slope node setup, except it is respecting the UV seam. So it's attempting to distort your texture map without introducing any seams. I'm sort of repeating myself here, but that's the point of all these adjacency nodes. So when I plug in my slope direction to the direction and plug in my source UV map, you can see that just sort of roughens up the boundaries. And when you're playing with this, I spent some time just finessing the element size here of the fractal noise. You can see you have to make it quite big since we're at such a large scale to get a little bit of breakup in this mask. And then I combine that with the original mask so we make sure we're still hitting all the seam points. So that is just taking this adjacency extrapolate, this first mask, and this mask, and then blending them together with a maximum operation. And at the end, that's what we have. So all of this is just a mask to isolate the seams here. And these are just nothing. You can see I was still experimenting with a bunch of nodes here, but that's the whole workflow. So if I preview this mask node, you can see I just have a sort of blobby highlight on the UV seams, and then I can use that as a mask to combine this eroded terrain, so we can see the little seam lines here, with my original height field terrain, which is perfectly seamless. So this original height field noise is seamless. The simulation introduces a little bit of seams, and then I just put both of those together, and you can see I'm just adding that original height field, almost like if you were, think about if you're in like Substance Painter with a clone brush. That's all I'm doing. I'm just cloning out those seams, so we no longer have a seam line. That is one way. That is sort of one way of dealing with the seams from the height field erode, and you could use that same seam mask technique, run another erosion after this, and pipe in the original. So that's one method. I'm gonna go ahead and delete this. Sorry for the spaghetti wiring here, but in general, just know the idea here is make a UV seam and then blend in your seamless stuff over your non-seamless stuff, and you're golden. Now I was experimenting with another workflow here where I'm using the height field erode within a block. So a block is essentially a for loop, so it just iterates over and over as many times as you want. So what I tried to do here is, I'm going to go ahead and recreate this because to just make it evident, is instead of running the height field outside of a block like 7 iterations, I run it inside a block at 1 iteration and then use the adjacency extrapolate node every time to try to minimize the amount of seams that occur. So like the more and more erosion occurs, the more and more the geometry deforms, and the more likely you get those UV seams, or at least that's the thought behind this. So let's go ahead and set this up here. I can take a block, I can select both of them, and I can add an input. And our first one, you could name it whatever, but it's really our height that we're taking in first, and that's a mono. And then we also need to pass in our adjacency setup node. So I'll go ahead and set the second one to cable and adjacency. That is, I've been saying that word and reading it so much I have no idea that's how to spell it anymore. Adjacency. I think I misspelled it down here. Adjacency. Well, adjacency. You get the idea. So I'm going to, we actually don't need that on the output, so I'll hit the minus. We just need to output the height. And so we're going to pipe in our Heightfield terrace. So that is this, where we left off right in the beginning here, into the block. And in the adjacency slot, we're going to plug in our Geo2 adjacency. And now I could put down a Heightfield erode, plug in the height to here, and plug in the height to here. And so instead of setting this Heightfield to 5 iterations, I'll set it to 1. And what will iterate on it is the block itself rather than the erosion node. So if I go over to the end block here, you can see every time I up the iteration, it is essentially running that erosion over and over again. And so what that allows me to do, I'll set it to something like 5, is use the adjacency extrapolate node every iteration to try and make these seams a little less evident. So I'm going to put down an adjacency extrapolate node and put that right before the erosion. So I'll plug in my height right here, height to height. I get an error. I also need that adjacency cable plugged in. And you can see here, still not so great. If I sort of preview before and after, it's sort of better, but we're still getting a little bit of that seam. So it's improved, but still not perfect. That is where I sort of have combined this with some other tools to sort of have mitigate this, almost like my in painting up here. So what I have found is putting a dilate here. It helps sort of bridge some of those seams, and also I liked the look of it, where it's sort of flattening, making some of these craters a little more evident. So I'm gonna just kind of match this. So I put this to -4, and it sort of defines some of these shapes a little bit. It's not really helping that much with the seam, but stylistically, I like the look. And so we're still having seams. Here's before and after the dilate. So it's sort of just almost like a contrast to your terrain, adding a little more ridges into there, ridge definition. But what really helped was using the adjacency distort node and then redistorting sort of over the border here. So I'm going to go ahead and put down this adjacency distort, plug it in after the erode, plug in the adjacency node, and what I'm going to use to actually run the distortion is a Heightfield flow. So I'm not going to use the flow from the Heightfield erode itself. I found like that didn't work as well since it's updating every time. This is all sort of theoretical. I use the Heightfield flow node and just hook that into my original extrapolate and use that flow parameter to drive the direction. And you can see once I do that, this is pretty powerful, but it's starting to cover up some of those seams. We can still see a little bit here, but if we sort of glance around, we really aren't noticing much seams. This is probably the most egregious point right there. And I reduced the scale quite a bit here and set the streak to blur on the adjacency. So scale to negative, turn on the blur. And you can see now we're almost looking good. So that area looks a little bad, but if I kind of look along these seams, we're really not noticing it in a whole lot of other areas. I'm just double checking. So there's that seam. If I get really close, we can notice it. So I still have a little bit of a seam there. And what I would do, I'm going to delete that setup. So this is the exact same sort of block. And what I would do if I wanted to completely eliminate that seam, so I'm switching between 2D and 3D view, is I would incorporate my texture painting, or I call it texture painting, but this sort of seam masking workflow back onto the object, just in these sort of areas where it's not connecting. You could, if you wanted to, do like a custom mask and just paint those out if you were really diligent. But once you add everything else on top, you don't really notice these little inconsistencies here. So let's keep walking through it. So that's basically one level of erosion with this block. And you could iterate as many times as you want on that to get different effects if you want more or less erosion. This is how the sphere is looking now. And then what I do is basically just repeat this block with a different sized erosion. So same exact idea here. In this case, I'm trying out the flow from the erosion to drive the distortion. And this is where I'm playing around. I'm testing. These things are brand new to me as well. There might be certainly a better way of doing this. And you can see I'm getting a little bit of a seam occurring right there. But then I go back in here and I run a Heightfield strata on everything, which then still introduces more seams. So we're starting to get some pretty noticeable stuff with the Heightfield strata before and after, but this is adding all those nice ridges all around. If I up the amplitude, you can really start to see that. And so then I do the adjacency extrapolate again to try to sew up those seams a little bit. You can see it kind of does, but not really. And then at the very end, I'm taking my seam mask workflow and just sort of in painting all of those seams with my seamless terrain again. So I'm going sort of back over, to my last iteration here, which was pretty much seamless, painting that in to cover up any of that strata seams. So you can see before, after, or even before, after. And that's the Heightfield. So hopefully this hasn't gotten too long here. You can see I do still have a couple of points that are disconnecting a little bit. I didn't bother with it, but I could always go back here with the seam workflow and merge in my very early distorted terrain. So I'll take my very first noisy terrain, bring that back in and merge it over, and then we could cover up all those seams really nicely. You do start to get a little bit of noticeable sort of breakup since we changed it so much with the Heightfield erode, but this is where you could use your artistic license to sort of paint in some mask and approach it in different ways to cover up any of those connections. But overall, not bad. It's definitely like there still are a little bit of noticeable breaks here and there, but if I just rotate all around the sphere from like a planetary distance, let's say, you're not going to really notice any of that stuff. There, that one just caught my eye. So if this were like your final train, I might go in and just in-paint that little bit with that mask workflow. So then I just use some of the coloring techniques that have been shown in other Heightfield videos. So just converting the Heightfield to a mono, using a ramp to tint that. I just decided to keep it more grayscale, almost like asteroid-like. And that, there you have it. There's your color map for your planet, and here's your Heightfield. So there's two ways you can use this on your actual geometry. One, you can just write it out to disk. So you can use a ROP image output node and just drag and drop the node you want to output onto the COP path, and then fill in the output file location if you want to write that to disk. Or you can directly reference your COPNet in the material in Solaris. So let's jump over to Solaris and look at some of the rendering of this. All right, so here we are in Solaris. Let's take a look at how we apply those textures to a material and some of these other little finishing touches that really help make the planet pop. So I'm gonna go ahead and switch just to the Vulkan viewport. Okay, so here we are looking at the planet. I'll just walk through the node structure here. It's pretty standard. We have a SOP import that brings in the planet, that is that subdivided box that we originally used, into Solaris. I'm using a render geometry setting just to set the dicing quality to 1, which just gives you a better displacement, more accurate high-res displacement. And I just changed it to bump added to displacement just to add a little more bump detail. And then what I'm doing is I'm importing the planet again, same exact SOP, and I'm using it to make like a sphere of water so we can have a water layer on the planet. And I use a transform node just to sort of adjust where that water level is. I'm also bringing in some clouds. I'll show you how I made these clouds in a second. And then I'm just using a transform node on everything just to spin it around. So really the magic is happening with the materials here. So let's dive into this material library and take a look at the planet map. So what I'm doing here is there's two ways of going about this. I'm going to go ahead and just disable all this other stuff so we can look at just the planet in isolation. And let's look at it with some lighting. So I just have two sunlights here to get like kind of a sun and a moon effect facing opposite angles. And inside the material library here, I've made a Planet 01 map, and I'm using a, just standard Material X here. And you can bring in your textures if you write them to disk, just like a normal texture with a image node, Material X image. But if you're working live, and this is pretty cool, you could use the actual COPNet. So the syntax for this is you just put OP : operator : in front of the path name. So if I go all the way back to my COPNet here, I'm going to press the pin on my viewport to keep it in the rendering view. If I jump back here into the COPNet, you can see right here I have a null called base color. If I just press Control C, select it, then press Control C, that copies the path. And I can jump back into my material network here. And then I can just press Control V on the file name, and that fills in the path. And then if I just put OP : in front of it, that will reference it. So I could use that instead. I made this little dot so I could switch between the texture on disk and the live texture. I could hook up this node. It's going to recompute the other node network, which is at 4K. So just give that a second to run through. So now if I go back to the COPNet here, I can adjust the textures on the fly and see them when we render. So if I disable like my color correct, now we are getting a live update from that COP network. So you can work really interactively. I can turn back on the render. This might slow down my stream just a little bit. And I can preview how things are looking. I can go to the ramp, show all, maybe play around with some of these other versions of colors here. If I go back to the stage, you can sort of see this, how this is looking. Looking a bit shiny because I'm having the color also drive some of the roughness. So I would have to dial that in. The other thing I'm doing here is I'm taking the height map and I'm using it as a mask to sort of emulate more water, like, you know, ocean bottom areas, and just simplify that shading. So I bring in the height node, and that is just driving the displacement, but I'm also remapping it to a specific range and using that on a few mix nodes, so I can mix between this sort of blank ocean color and the more above water terrain color. So if I adjust this, so I can use this to sort of raise and lower the water level. I could switch out of Vulkan just for faster feedback, so you can see how this works. So you can get some interesting effects with this. And now we're having like a whole different sort of vibe to this world. More like a weird forest world or something. And you can tweak this. You could add color corrects. You can color correct it back in the comp. You can color correct it in the material. Lots of ways of going about this. I don't really think the yellow here is working so well. So I could take out some of these yellow points, for instance, if I wanted those to be less. I could add a new color correct here if I think it's getting too dark, and go to the shadow layer and maybe up the shadow a little bit. Lower the contrast. And you could get a whole different look, right? So you get the idea here. You can adjust the textures in comp. You can adjust it. Oh, that's kind of cool with like a lighter planet. You can adjust it in the material, but essentially you're bringing in your COP network either on disk or live into your stage and plugging that into whatever you want on your material. And you can see it's pretty responsive, especially you get a lot of like instant feedback with the new viewport here, and the Karma renders are pretty spunky as well. The other things I did, I'll go through this. I imported the planet again, and I used a transform to make a little layer of water, and that's just a material with some transmission on it and tinting, and nothing fancy there. To get a little sort of like ocean, I could adjust the scale with this transform node to like lower or raise the water level, and I sort of dialed that in with the water tint, the ocean floor tint that I was doing on that earth material. So you could get some different looks with that. And then I'm adding an atmosphere, and what I'm doing is using the Karma fog box for that. And I just set that to also reference the planet, and then I just increase the scale. You could adjust things like your density, your color to get different stylistic effects. You might not even want the atmosphere. And then I added some clouds. So I'll show you how I did that in just one moment. And we're almost there. So let me jump back to the object context. For the clouds, kind of a quick sort of way of going about this. I just took the planet. I used an attribute adjust float to create a density attribute. So if I preview this, this is essentially like emulating where the cloud's going to be on the planet. So you could mess around with this noise and kind of get more or less cloud coverage. Then I use that to scatter points, and I ran that in a volume rasterize attributes to create this little cloud. So just a quick sort of easy way to do the clouds rather than sort of making hero clouds or trying to use the sky, Houdini sky. And that worked for my purposes. One last cool thing to point out with Houdini 22 and Karma is we have this new image filter setup. So on your Karma render settings, you can go to the image output tab here and then go to filters, and you can add filters. So you can just click the plus button right here and that'll add this little image filter node. And when I click on that, you can essentially add all these kind of quick post effects right to your render without having to make a COP net or anything or a slap comp. So it's just a nice quick way of adding post effects. So you can see if I do add filter, I added a denoiser, I added the little star glow for some glow effect, I added a little chromatic aberration and tone mapping. So great way. I think there's a lot of sort of ease of use or quality of life with that, so you don't have to spend time setting up the slap comp and having that actually feed into your final rendered plate. All right, so that's basically it. There's my tiny planet. You could customize all those noises and erosions and terracing and mix it with other COP nodes to get your own unique look, or alien worlds or stylistic worlds or cartoony planets. Really, the sky's the limit at that point. Main idea here was using some of those adjacency nodes in order to get a more seamless height field on a 3D surface. If there's any questions about that, I know there was a lot of sort of nodes walked through there. Let me know in the comments. Send me what you make. Thank you. Thanks for watching.